Okay, hello again. So today we will try. The name of the challenge is DetectLog4J. So this vulnerability was quite viral in the last Q4 last year. Okay, so the challenge details. So we will be dealing with and inspecting a disk image here, Windows disk image, and we'll do a forensics on it. So really it's dealing with the log4 shell vulnerability. And these are the tools that we are going to use to solve the challenge. Okay, so let's start. This is a 25 challenge questions. The first one, what is the computer host name? Okay, so let's go to our analysis machine. First, we need to mount the image. So the image is in the downloads. So we will be using the tool, this one, Arsenal Image Mounter, used to mount EO1 images. There could be other tools as well, like autopsy and the like. So click on mount and then simply select the EO1 image and open. Okay, let's just wait for it to mount. You could select read only or we could do write temporary. Okay, let's just write temporary for now. Okay, and if you open the Explorer, you will notice it will be mounted to another drive. In this case, it's F. As you can see here, this is actually a C drive of the mounted image. Okay, so to find the computer name, we will be inspecting the registry key, the system registry key. So imagine this is drive C of the forensic image. The location is we see Windows system 32, then config. Okay, all the local machine registry hives are here. So we will be dealing with the security, the system rather. Okay, let's try to load that. So we'll be using a registry explorer. You could do regedit, but the registry explorer is much efficient tool for registry inspection. So you can download it from Zimmerman tools. So notice here I'm already pointing to the mounted image, F Windows 32 config, and let's open the system. Open. Okay, we'll give it a few seconds to load. And then we will expand the root. It's under the current control set, then under the control, and then you can see the computer name here. Expand it. Click on the computer name and you will get this. This is the actual computer name, BCW65. Okay. Okay, next, what is the time zone of the compromised machine? So this one, we will again go back to our analysis machine, and time zone will also be observed under the same registry hive system, but it will be under the control set. Then you could scroll down and you will notice this time zone information, and you will get this time zone key name equals to Pacific Standard Time. And if you Google it, PST is equivalent to UTC minus 8. Okay. Okay, next, what is the current build number on the system? So let's go back to our analysis machine. So this time we will load the software registry hive. Load hive to now open the software. Okay, give it a second or two. I think it will be load underneath. Oh, it's still loading. Okay, what happened? Oh, it's still loading. Okay, perhaps I'll pause this. Okay, it says finish loading, so it will be under software, Microsoft. Then let's go to be under Windows NT, and then current version. Okay, and then you will notice here current build. It's 14393, right? So we'll go back 14393. There you go. Okay, so next, what is the computer IP? Okay, going back, so it will be on system, control 001, then it will be under services. So here you'll have services, then under services, it will be under TCP IP. TCP IP, and then under that interfaces, and then you will actually find it in one of the interfaces. So here, this is the answer, DHCP IP. Okay, next, what is the domain computer was assigned to? So this is the domain. Now let's go back. It's actually just a few registry key. So go back to parameters, and you will see this domain. Okay, Cyber Defenders.
Okay, next, when was my OSEF user created? So we found this, so let's go back to the forensic machine. Okay, so this one, notice here, you have to open the SAM registry hard, okay? Then you have to go to the root SAM domain account, and then you will find it under, oh, not there, users, oh yeah, under users, and then under names you will find my OSEF. Okay, so in registry the last write timestamp is equivalent to the creation date of that specific user. Okay, so this one, okay, that's the last write timestamp key. And then the next one, what is the user M Hassan password hint? So we have to go to M Hassan. So notice here, you have to take note the last write timestamp, which is this one, 1228 0738, and then we need to find the corresponding user entry on just a few keys above. Okay, so 1228 738. So this one, 1228 738. Okay, this is the corresponding user ID. Remember there, some domains account users. Then go to the user password hint. Check the data within that, and you will find this decoded data. HTTPS link in 0x Mohammed Hassan, which is what we found here. Right?
Okay, next, what is the version of the VMware product installed on the machine? Okay, this is the version we got. So for this one, we'll inspect the software Hive, and you have to go to this key, Microsoft Windows current version, uninstall VMware BCS. And when you get to that key, so you could check the display version value. Okay, and you will get this. Alright. Okay, number 9, what is the version of the log4j library used by the installed VMware product? So we actually found this, and actually let's answer number 10 as well. What's the log4j library log level specified in the configuration file? So going back to the configuration machine, you could find the log4j version by browsing onto the program files, of course on the mounted image path, which is F, program files, VMware's vCenter server, and VMware's identity services. And you could find the log4j core file. The version is 2.11.2. And then what's the log level settings? So we will open that log4j to XML using Notepad++ here, and we just search for the word level, and notice here all the level set are in the info. So that's how we got the answer. Okay, 11. The attacker exploited log4shell through an HTTP login request. What is the HTTP header used to inject payload? Okay, we used up the hint here. So it is asking us to refer to this link. And as we check this link, it's quite a long article, and you'll actually find this. So it's actually exploiting the vulnerability in the X-forwarded4 header. Okay, that's how we go. Okay, next, the attacker used the log4shell.hackers.com payload to detect if vCenter instance is vulnerable. So what is the link? First link of the log4 payload. So we found this. So we actually used the hint here. Okay, as you can see, we are asked to inspect this path. So we will now browse to the path. So some VMware, uh, vCenter server, runtime, service, logs. You will find this audit events log, and we'll search for the first instance. Log4shell. Okay, you will find this. So this is the first link. Okay, number 13. When was the first successful login to vSphere web client? So we actually found this, and then we'll continue next on the 14. Since we will need to look on the same log file. So here, what is the attacker's IP address? So okay, first off, successful login. So we will use the same audit event log from the previous question. Remember this? This is the VMware vCenter audit event log. So actually on the very first entry, we can see here login success. And as you can see here, the user was administrator at vSphere, and here's the timestamp. We got it is, we just convert it to UTC. Okay. Then going back, what is the attacker's IP address? So remember, we have found the payload by searching for log4shell. And on the very first entry, we can actually see the attacker's IP address on the same line of the payload, which is okay. That's how we got this. All right. Okay, number 15. What is the port the attacker used to receive the Cobalt Strike reverse shell? Okay, so for this one, we will inspect the event logs. So let's open the PowerShell. Oh, sorry. I will use the event log explorer for this one. So open log file, open log. Okay, let's do right. So go back to the mounted image. F C Windows 32 32. Okay, bear with me. So I found that. Then WinEVT logs. Okay, we can Microsoft Windows PowerShell operational. Okay, So open it. You can use any tool, but I'm a fan of all things Sans. So and this one is really a good tool. Okay, here you notice here on the third event, of course, we're interested in the first occurrence of a malicious PowerShell execution, which is this one, third to the last event. So let's copy the obfuscated base64 string down to the last character. Then we will use cybershop recipe, um, combination of from base64 and a gunzip, and you will be able to decode the actual PowerShell script. This one, okay. So next thing is save this PowerShell file. So let's just save the script .ps1. Okay, sadly my fake DNS is not working here. It's not cooperating, but fret not. We have a workaround. So let's hash this first. The script that we saved earlier, the malicious PowerShell script. Okay, copy it. Then we can leverage sandbox like Joe Sandbox. Notice here I've already searched the SHA-256 and we got a hit. So simply view its action, view the entry, and it will output the detailed report. Okay, and then you scroll down, view the IOC, and you will notice this network URL connection. It's using the port 1337. 16. What is the script name published by VMware to mitigate log4shell vulnerability? So here, in the succeeding questions, we'll utilize the hint. So here, you're directed to a reference article. So if you open it, you could actually see the name of the script for to mitigate log4j is this one. Alright, so next question is also a research one. So in some cases, you may not be able to update the product use in your network. What system property needed to set to true to work around the log4shell vulnerability? So this is the actual property that needed to be set to true. So the hint will redirect us to this article, and you can actually see here the answer, this one. Parameter, format message, no lookups, needs to be set to true. Right? Then moving on to the next question, what is the log4j version which contains a patch to this CVE? So again, we use the hint because it will direct to a specific article, and you can actually see the answer here. This one. So fix in the log4j 2.15.0. Okay, next, removing JNDI lookup. That class may help in mitigating log4shell. So we are asked to find the SHA-256 of the JNDI lookup class. So we found this. So let's go back to our analysis machine. So in the mounted image path, you have to browse the program files, VMware, vCenter, VMware Identity Services. And we need to extract the contents of this jar file, log4j-core-2.11.2. To do that, simply right click and we should extract files. Okay, let's direct it to somewhere. Example in the documents. Let's documents and then create a new folder. So log4j jar. Okay, then simply extract it. To extract the content, so go now to documents, and this is the folder where we extract the jar file. So go to the org, Apache, logging, log4j, core, then look up. and you will find the JNDI lookup.class. This is the file. Simply right click and do a CRC SHA, and we are looking for the SHA-256. Okay, that's how we got this answer. Okay, then we are to analyze the JNDI lookup class. What is the value stored in the container? This one variable. So if we go back, we can open that using a Notepad++. Notice here this is the variable container JD resource path. Okay, it's quite garbled, but actually just browsing it, and we can browsing it there we can actually see the actual variable parameter. Aha, which is actually this one. Okay, we'll go back. Okay, actually in the hint you could also do this, but I don't have JDGUI right now, so we just manually scan using the Notepad++. Okay, can be either actually. Okay, next, what is the executable used by the attacker to gain persistence? So we found this backdoor.exe. So we will again do registry forensics. So using your registry explorer, load the user hive of administrator.win and this one b603. So once you're in that path, so you will get this, and then we'll now inspect the run keys. So it's under software, Microsoft, Windows, current version, then the run on run once key. So we have none in the run key, but we have one in the run once. This is actually the executable. Okay, next, when was the first submission of ransomware to Virus Total? So we found this. So let's go back. So remember on the mounted path, it's mountain F. Okay, let's try to get the hash SHA-256. Right click and select SHA-256. Then you can copy this one, double click, and you can copy the hash. The search total. Here, go to details. Okay, you can see here the first submission. That's how we got the answer. Right? Okay, number 23, the ransomware downloads a text file from an external server. What is the key used to decrypt the URL? So here we will use the hint, and the hint says to use the NSPy. Actually, the hint already gave the answer as well, but I will walk you through how to get it. So, okay, so have here the NSPy, so you can download it via GitHub. Just search here the NSPy and releases, and for Windows you could download a 64-bit or 32-bit version of the DNSPy and just launch it, extract it. It's actually a portable executable, so you will have something like this. Then simply launch it, double click, and then you will have this. And then let me just start over. To do file, open, then direct to the Consari malware, open. Then the hint says let's go to right click and go to entry point. Then observe this variable. Actually, if you move, if you'll observe this string passing event that's happening, I notice here that text3, this string will be passed on to text3, and then text4 will get the text3 variable, and then this VNN variable will actually have this value eventually. Okay, so that's how we got it. So next question, what is the IP that ISP that owns the IP that serves the text file? So recall in the earlier questions, we look up the ransomware by virus total, and if you go to the relations, you go to the contacted domains. Notice it's actually contacting an Amazon domain, right? Then the last one, the ransomware checks for the extensions to exclude them from the encryption process. So what is the second extension the ransomware checks for? So we found here ini. So if you will Google, actually, we just did a Google search for this one. So Google search Konsari malware, and you'll eventually find this one that details or analyze this malware in detail. So open that one, and you will find just further below on the report, this one, the so the author was able to do, and as you can see here, uh, the strings that consari and that ini are being skipped by the malware during the encryption. Okay, that's how we found this. Right? Oh, sorry. Okay, and congrats. So hope you learn a lot during the CTF challenge.